Okay. Yeah, so that works. Okay. Hello, everyone. I hope you're not too disappointed that I'm here. I'm actually super excited to be here. 2 years ago at NGB was the first time that I did a training at a conference. So now the first time that I talk at NGB, so I'm super excited. I hope you are equally as excited as I am, even though we're just before lunch and I'm not who you expected that I was going to be, but bear with me. So I want to talk about Angular in the microservices world. And to kind of see what I want to talk about, we first need to take a step back. So if we look at software architecture and how we used to create these applications, or maybe still today, we used to create these giant monoliths. And a monolith is a software architecture where all the components are really tightly coupled together, front-end, back-end, talking to a single database instance. And that actually worked really well for a long time. And for some companies, it might still be the best choice. If you're a small startup and you only have 2 or 3 developers starting with a monolith that you can later split up, it's not the worst idea. But of course, monoliths do not scale on an organizational and an infrastructural level. So at some moment in time, we started splitting up applications in front-end and back-end, not only for the reason of not scaling, but also because newly created JavaScript frameworks, such as AngularJS, gave us the option to provide our user with a better user experience. And nowadays, the trend in back-end development is to work with microservices. I see a lot of companies trying to use microservice, with the focus on trying, I guess. But they are doing that. But in my opinion, what I see at a lot of companies that I go to, we are still creating these small monoliths inside for our front-end applications. So small monoliths, not big monoliths anymore, but small ones on top of microservices. And that's what I want to focus on today. I want to see what we can learn from the splitting of microservice in back-end world, and what we can see and how we can apply that into our front-end development. So a little bit about myself. My name is Kwinten, as Carmen already introduced me. I'm a freelance front-end architect. I'm also a meetup organizer, the GSB meetup, which is all about JavaScript. I'm the co-founder of a company called Strongbrew, and @QuintenP is my Twitter handle. So a little bit about Strongbrew. Strongbrew is a company that focuses on giving trainings, code reviews, and helping companies create architectures for mostly Angular applications, NGRX and RxJS. We gave these trainings also at conference, like this is a picture from last year at NGBE. And we also have a blog with some articles on there. One more thing I want to say is that 2 days ago, Dominic, who's in front here, and I released Angular Checklist, which is a list of curated best practices in the form of a to-do application. So you can see whatever you're already doing, and you can see what you can or should improve. But back to the topic of today. First, to know what we can learn from microservices, we need to look at some differences. And the first difference I want to tackle is runtime. When we have a microservice or a backend application, we are running that backend application inside of our cloud environment. And we have control over that cloud environment. Whenever we need to scale up, we can just deploy multiple instances. And that's something we can do in backend, but not in front-end world. Because in a front-end world, we are deploying our applications as static files, but the application itself is running inside of the browser. And that's a huge difference, so we do not control the runtime. And in a worst-case scenario, we even have to support IE, for example. Second difference, shared process. Microservices, they run in their own process. You have a single service that has some database, and it communicates to other services, and to do that communication, it's using protocols, such as REST or maybe an eventing system. But in front-end applications, we do not have that. We have one single JavaScript thread where all of the code is running. And this is a huge difference because we have to think about versions and frameworks and dependencies, and they all need to be compatible because they are running in the same process. We have that binary coupling that we do not have in a microservices world. And that's a huge differentiator as far as I'm concerned. To have a common understanding, what I said in my introduction on how I think that applications are being built today, let's take a look at a deployment overview. So we have some microservices, of course, very simplified view as it's not the focus. And on top of that, we have some Angular applications. For example, 4 Angular applications, and they all use some APIs to fetch some data. They all use a UI kit to have a consistent look and feel, and they have some features that are built on top of that. And from a deployment view, this is actually okay. We have these applications. These applications can be deployed independently. So I actually want to keep this. But it becomes a problem if we look at this from a team perspective. If we look at it from a team perspective and who is working on these features, it's always one application that is being developed by one team. So in this scenario, we would have 4 teams working on 4 applications. And the problem here is that I feel that companies, inside of companies that I see, these teams are not communicating with each other. They are not sharing any code. In a microservices world, services are built around business domain, and you have one team working for that specific business domain and creating all the code necessary. But in our use case, we have different API integration layers, for example, and these are being recreated over and over again by different teams. And that is a problem. We are not sharing code. We are not thinking about the structure of our application, and we are duplicating over and over again. So how would I want to do this? Well, I would want to have teams, and all of the teams would be responsible for some parts. And I want to divide all of the applications or all of the code that needs to be developed between these different teams. And then we can actually share that code. We can see that, for example, the UI kit is only going to be developed once. And it's not going to be redeveloped over and over again. So that is a huge win, and not only for the UI kit, but also for API integration layers. If a backend service changes its API, it needs to be updated everywhere. If you only have one single instance of that, it's only one single change that you have to do. So that's a big difference. So we need to go to somewhat of a modular approach. And when you say a modular approach, I think of Angular. Angular is a front-end framework that gives us the ideal way to split up applications into modules. We have feature modules. We have shared modules where we can put some shared components in. So Angular really facilitates working like this because it provides us with that modular structure that we can share. So how would that work? Well, when we have the applications and we have an overview of all of the features that are already developed, well, every application can just choose whatever feature they need to build up their application. So even though we have the same thing, this is the deployment overview, is the same thing, but for example, the API layer here, that is the same code that is just being bundled in multiple applications. So we only have one instance, and we can have one team that is responsible for maintaining that API. And that is a huge win as far as I'm concerned. So we have modules, and we want to share that code, but how can we share that code? And the first thing that springs to mind is using NPM. Publishing a package on NPM, I guess most of you already did that once. And if you already publish something on NPM, so all the features in separate repositories, and you communicate through an NPM registry, if you've already done that, you know that this is a huge pain in the ass. If I develop a UI kit, and I develop it for Angular 6, and a new team starts, and they start using Angular 7, I have to update my UI kit. But what if I still have teams who are working with Angular 5? Then I have to support multiple versions of my UI kit. What if we start doing this for API layers as well? Then it becomes super difficult to manage, and this is something we want to avoid. So we're not going to use NPM to do this, to manage our modules, but we are going to be using something else. And that something else is called a monorepo. Now, what is a monorepo? A monorepo is a repo where all the code for all the front-end applications is in the same Git repository. And now you might be a little bit like this. And this is exactly what I felt the first time that I heard about monorepos. Why would you ever put everything in the same repository? That will not work. But if you think about it, it actually makes a lot of sense, because in a monorepo, you only have one package JSON file. If you only have one package JSON file, you can only have one single version of Angular. Having one single version of Angular means that all of the code that is created inside of that repository, which hopefully is all of the code in your organization, but all of that code is automatically going to be compatible. And that is a huge differentiator. You don't have to use NPM anymore. You can just use the monorepo. Everything is on the same version, automatically compatible. And that is a huge win. It also allows us to do other stuff. One thing that I like is when I go into an organization that they all use the same standards. For example, for linting, they all use the same linting rules. But having a monorepo allows us to put one TS-lint JSON file with all of the common configuration, which of course can be overridden, but all of the common rules that everyone should follow in a single location, automatically for your entire organization. So that is a huge win to me. And remember, this is something we need to do because the difference between microservices is that we have that binary coupling. When we are building our applications, we are coupling everything, and it's going to run in the same thread. So compatibility in code that is created is extremely important in our scenario. One thing I want to say, though, is that a monorepo is not a monolith. And this is something that I feel is often misunderstood. So a monolith is a software architecture where all the components are tightly coupled, while a monorepo is just a single repository. But we can perfectly put our Angular modules in the same repository without that impacting the fact that we're not using a monolith. We can use a modular monorepo, and that's what we want to do. So how are we going to do that? Well, Thor said it this morning in his talk. He works for a company called Narwhal, and they released something called Annex. And Annex allows us, or helps us, to facilitate the development with a monorepo. So Narwhal, company founded by two ex-Googlers, Jeff Cross and Victor Sefkin, and they created Narwhal, and they open-sourced Annex, and Annex allows us to create, or somewhat create, Angular applications like Google does it. So it facilitates the development with a monorepo, but what is really important in my point of view is that it's only a really thin layer on top of the CLI. So Annex is actually nothing too special. It's only a thin layer that facilitates the monorepo development. And I know for a fact that some of you might be thinking, well, if I use Angular CLI version 6, I can already have multiple projects inside of inside of one repository or in one CLI project. That's perfectly true, but Annex helps us to scale that. And to see how we can scale that, we're going to build an example front-end. And I want to focus on the fact that I used the word front-end here. I did not use the word application, because in bigger organizations, or even in small organizations where we have multiple applications, it makes sense to think of our applications not as being separate applications, but as being part of a bigger platform. We have different teams working on different applications, but from our user's point of view, he should not know who created the application. Applications are part of a platform, and the platform should have a unique, a consistent look and feel, and a consistent behavior. That is really important. So we're going to create something for an e-commerce company. So we have a web shop and stock management. We have few feature modules or some libraries. We have a UI kit. We have a product payment and stock service, and we also have an authentication service. The web shop is going to depend on some of these modules, and our stock management is going to depend on some of these modules. So let's get started. And the first thing we need to do is we can use a binary, and that binary is called create Annex workspace, and that is the only non-standard thing you have to do when using Annex. It's a binary that allows you to create a workspace. What is a workspace? So I'm using the name demo here. What is a workspace? A workspace is nothing more than an empty Angular CLI project. So let me show that, what it looks like in code. So I'm not going to run this live because it takes a little bit too much time. But this is an Annex workspace, and it kind of looks familiar like an Angular CLI project. So we have an Angular JSON file here. We have some Karma configuration, our package JSON file, only one package JSON file, of course. And then we have this. We have an apps folder and a libs folder. And this is something important. Oops, let me zoom out. Okay, the zooming is broken. Okay. Let me quickly remove it, zoom out again. So note to self, do not zoom anymore. What? Zoom to fit. Okay. Yes. Okay. So my zooming is totally broken. Okay, so I'm going to quickly reboot my computer. But I'm going to keep on talking in the meantime. So you saw that we had that apps and that libs folder. This is so fun. We had that apps and that libs folder. And it's actually really important. So in an Annex workspace, we differentiate between two things. Whoa, that was fast. Password. Okay, so we have apps and we have libs. And what is an app? An app is what you would normally have in a CLI project. So that is an application. You can build it, you can serve it, you can get the static files. But we should not put any shared code in there. To handle shared code, we have libraries. And libraries in an Annex workspace is nothing more than a folder with some TypeScript files. And these TypeScript files can be anything. That can be an Angular module, but also just some plain TypeScript files. I'm going to plug this in again. And all the code that we need to share inside of our application, we're going to put that in libs. So what is the difference between an app and a lib? A lib is for all of the shared code, and an app is nothing more than an aggregation of different libs. So we can have a lib which is included in multiple. Let's click open. Oh, see that. What? Okay, let's open my slides. Where are the slides? Can you zoom in a little? No. Zooming is not an option anymore. So we have those libs, and those libs are being shared between the applications. And now it would be cool to have my slides. Okay, nice. Okay, so we have a folder structure, yeah. So next thing Annex gives us, and this is already, again, standard, it gives us schematics. So what is a schematic? Schematic, whenever you run ng generate component, a schematic is going to run to scaffold out that code. And Annex has its own schematics to generate code for us. So I talked about applications and libraries. Well, they give us two schematics to run to create applications and libraries. So we can use ng generate app webshop and stock management, and we can do the same thing for the libraries. So that's just going to scaffold out the code for us for an application and a library. But now we need to create links, because this is the stock management module. And in the stock management module, as you saw on the previous slides, we depend on a few modules. So I'm going to import these modules here. I'm importing them normally now, but you can also import them lazy-loadedly. And this is nothing too special. You've seen this before. But what is a little bit special is the way that we import them. So if we look at an import, we can see, for example, that if we import the stock module, we're importing that from @demo/stock. And this is something really important. This is called the TypeScript path mapping, and it has a fixed structure. We're always going to import from @name of the workspace, in our case demo, /libname. And that's how we create links between applications and libraries. And these imports are extremely important. And I'll come back to that later why. So this is called a path mapping. Again, nothing from Annex. This is just a TypeScript feature. And that TypeScript feature allows you to map a certain path to a certain directory. That's everything it does. And you can see, and this is also important, that we point to an index.ts file. So we're going to point to the public API of our library. Next thing Annex gives us is TS Lint Rules. And the TS Lint rule that they give us is called Annex Enforce Module Boundaries. And the first thing it does is it will enforce that we only communicate with the public API of a lib. When we create a lib, for example, an implementation of an API that we share between different applications, we want that lib to not have leaky abstractions. Our applications or other libraries should only use the public API. But of course, we use editors, and editors do imports, or we type our imports ourselves, and we tend to screw up. So Annex gives us a TS Lint rule, and that TS Lint rule, and now I'm definitely not going to zoom anymore, but that TS Lint rule allows us, so if we have the app module, for example, for one of the, and I import something from a non-public API, you can see, if it works, you can see it's not readable, but I'll say what it says. It says deep imports into libraries are forbidden. So that TS Lint rule helps us to only communicate with public APIs. Next thing, imagine that you have a workspace with 20 applications, 20 teams working, or maybe 10 teams. Teams are working on multiple applications in the same repository. At some point, it might make sense to maybe not want to do all of the imports or not allow all of the imports. For example, if you have a UIKit module, and in my UIKit module, I don't want to really import something in there. If I have an import from my stock module to my UIKit module, so my UIKit module imports it, that's actually a problem, because now everybody who uses my UIKit module is also going to get the stock module, and I don't want that. So what Annex does is Annex allows us to define the relationships that we allow. And this is a really cool feature. So what we have inside of an Annex workspace is an Annex JSON file. And in this Annex JSON file, we can give every application or every library, for example, we have the UIKit, we can give it certain tags. So here I'm giving the UIKit library a tag UI. And when I go to the allowed relationship, so this is in the TS-lint JSON file, I can say, for example, that if you're a UI lib, that you can only depend on, and actually in this case nothing, because I gave it an empty array. And this allows us to make sure that we don't have any wrong imports. So again, the same TS-lint rule that helps us with the public API also helps us to make sure that we don't have the wrong imports inside of our application from different modules. So again, to show this, if I go to the, so I'm gonna undo this. If I go to UIKit module, and if I try to do an import, for example, to the payment module, it's gonna give us a TS-lint rule, and this one is saying if your library depends on this tag, you cannot import anything other than these tags. Of course, this one is empty because we have not, a UI library cannot depend on anything, which makes a lot of sense. So we have our example front end, and now in the code, I've already set up all these links. So we have the applications. The applications are deployable units, and they aggregate some libraries. So we have these libraries. We do not put any code in the applications, because that would mean that we cannot share that code. So we have that front end. And if you worked in a microservices world before, this could be referred to as a town plan. A town plan is an overview of all the microservices and how they are interconnected. Who depends on who is calling who. You could kind of think of this as being the town plan of my example front-end application. And that is pretty cool. But the problem with plans or diagrams is that they get out of date really quick. Of course, this is a problem, because I always want to see the last version. And what Annex gives us, Annex can statically analyze our code, and using dependency graph resolution, it can actually build up this graph for us. So what Annex does, I'm going to show this first, it will make more sense. So if let me reset here. So if I run yarn depth graph, which is running a script from Annex, it's going to analyze my code, and based on the code, it's going to generate this graph. I hope I can zoom in here. That won't break anything. So it's going to analyze the code, and it's going to generate this graph from the code. So this graph is always going to be up to date. So it parses all of the TypeScript files, and when it parses a file inside of the stock module, and it sees, or in the webshop module, for example, and it sees an import to add demo/payment, for example, then it knows that the webshop depends on the payment. So that is something I believe is really cool, because we can have this always up-to-date view. I can also use it, for example, when I want to change something to the payment module, I can see all of the applications that I'm going to impact. And that can be cool to have some communication. So I think it's a really awesome feature, which I use a lot. So if we go back to the slides, you can see that we have the same thing here. Last thing I want to talk about is building. When we build our code, how I usually do it in CLI project, I build out my code, and every time I do a commit to a branch or to the master, kind of depends, I'm going to trigger a build. I'm going to run linting, I'm going to run testing, and I'm going to run end-to-end testing. And this is really cool. It works. I'm pretty sure that everything is going to be up to date. But of course, in a mono repo, that does not really work. If I have 10 applications and I have to run the end-to-end test for all of the applications every time I commit to the master, that might become a problem. So we don't want to do that. So how can we fix that? Well, using the same tools that we had for the dependency graph resolution, Annex can actually has some build scripts, and what you can do is you can pass commit hashes to those build scripts, and Annex is going to look, and it's going to see, okay, in these commits, you change these files. I know that if you change these files, they belong to this project or this library, and I know this library impacts this application, for example. So based on that, it will tell us what we need to build. So to give an example of that, so in the README file here, I have a I already did the commit, so you'll just have to trust me on this. But in this commit, I did a change to the UI kit module. And if I go to the terminal and I run this, it will do that analyzation that I said, and it says that I need to rebuild these two applications, which makes sense because my UI kit is something that these two applications depend on. If I do the same thing, but only a change to the payment module, and I'm quickly going to change this to apps because it's a little bit faster, it should only say that I need to build the web shop because my stock management does not depend on this. So on your CI environment, you can actually check using these scripts, or you can even call, so I did affected apps here, but you can also say affected build or affected test, and then it's only going to run testing for whatever is affected. So when I commit something to my mono repo, I'm only going to check whatever was impacted by the change that I made. So that's really cool. It makes it a lot faster. Of course, you've all seen Thor's talk this morning. When we have Bazel, this is something that Bazel will probably take over, but of course we want to write code today as well. So this is something we can already do using Annex. So to kind of summarize, this is basically, Annex also has some runtime libraries, but this is basically everything that Annex gives us to facilitate the development of a monorepo. And if you look at this and you compare it to a normal Angular CLI project, where you can just have projects, all of these features of only building what you want to build, the dependency graph resolution, the TS Lint Rules, you don't get that. And that's what you get with Annex. So it's a huge benefit, which I really like. And this is the quote that I want to really focus on, because this really resonates with me, and it's a quote from Alex Eagle, who works with the Angular core team for the Bazel integration, I think. And he says that if you don't have a monorepo, you're not really doing continuous integration. You're doing frequent integration at best. And that makes so much sense, because imagine that I have a monorepo with 5 applications and 10 libraries, and I change something to a library, I can create a commit, I can push that to a branch, a Jenkins build or a CI build is going to be triggered, and everything that I impacted with my change, is going to be automatically linted, tested, and end-to-end tested. So I know, or I have way more confidence that my change did not break anything. If you have a UIKit module and you publish that on NPM, hopefully you've tested your change in an application, but maybe not even that, but you never tested it in all of the applications that you impacted. So having a monorepo really allows you to have that continuous integration that we all want, because I don't want to be called during the evening because I did a publish on an NPM package that broke something that was automatically deployed, blah, blah, blah. I don't want that. I want to see in my pull request, if I change this, will I break something? And that's really cool. So this really resonates with me. So what have we learned? I think that we should stop developing our front-end applications as small monoliths, but we should start thinking about a way on how we can develop features and reuse features in different applications, reuse features that were developed by other teams. And the way to do that, which I feel is the easiest one nowadays in front-end development, is using Angular for the modular approach and using the monorepo for the code-sharing ideas. That really helps. One thing I want to add before I finish up is that, of course, monorepos are not all rainbow and sunshine. As with all development or all software, everything comes with trade-offs, and monorepos do as well. For example, if you have a certain version inside of your monorepo, everything is on that version. That's a huge win, but it can also be a downside. What if some application uses a dependency which has a bug which is fixed, but then you have to upgrade to the next version? But if they want to do it, everyone needs to upgrade. And maybe not everyone is ready. So that's kind of a problem. So using a monorepo is something that should be supported on an organizational level. If your organization or your main manager or your main architect does not support the idea of a monorepo, I think it is really hard to manage, because you do need some processes and some procedures to manage the development of a monorepo, because you need that communication between teams. But of course, as everything has downsides, the upsides in using a monorepo, an Angular monorepo, for me outweigh the downsides by a lot. So these are some references from Manfred and James Henry, which I use for my talk. what I talked about today, we also gave this in a workshop yesterday, and especially for today, you can have the discount code. We're organizing it next year in April. It's NGBE discount. We'll give you a 20% discount if you claim it within the week. And that was it. Thank you very much.
Thank you very much.